Welcome to this webinar on YouTube, first time, at least for our C++ tools. We have Clare with us. Hi, Clare.
Hello.
And also Phil. Hi, Phil.
Hello again.
Clare will be covering unit tests with CLion, and hopefully you'll get some testing superpowers after the webinar. Sorry.
No refunds if you don't.
Yeah, sorry for that. So yeah, we have our speakers and we have this agenda for the day. So these things we'll try to cover in 1 hour webinar. But before we start, if you've never been to the YouTube webinar, and actually that's our first time here as well, so there is a live chat where you can ask questions. And together with Phil, we'll do our best to answer all the questions in the chat or follow up later in the blog post. And we'll also try to voice some questions and address them to Clare. So if you have any question to Clare, please feel free to ask them in a live chat. And the webinar is going to be recorded. So actually the recording will be available right after the webinar, but the whole blog post with all the questions and all the details will be available during a few days. So follow the announcements in the blog, in Twitter, or we'll simply mail you if you are registered to this webinar. And yeah, with that, I think I pass the stage to Clare. Clare?
Hello, everybody. Welcome, and thanks very much for joining. This slide has got my Twitter handle and my email address on as well. It's the only slide that does, so do take a note of that, but I'm sure we can add it to the blog post later on as well. And thanks to JetBrains for the invitation to give this webinar. So just a quick overview. I'll talk briefly about testing with the Catch2 test framework, Phil's test framework. We'll talk a bit more about using approval tests. We'll spend more time looking at code coverage in CLion and using code coverage to improve our tests. And if there's time, a little bit of CLion testing tips as well. So that's the broad structure. Now, what prompted this topic from me is I really enjoyed a webinar from a few years ago given by Arne Mertz, in which he showed some really powerful refactoring steps inside CLion. And he began with the absolutely correct, before we start refactoring, we want to have tests, and the tests are green so we can start refactoring. And about halfway through, somebody asked, what if we don't have tests? And Arne said it's a prerequisite for any refactoring. And I thought that was perhaps quite a good cue for a good prompt for a webinar on how you can add tests when you don't have any. So that's the sort of high level goal of today's webinar, what to do if we don't have tests. And I want to just say from the outset, obviously I'm going to be looking at quite a specific chunk of code, but the techniques that I'm using generalize to other types of code, many other scenarios, and also much larger volumes of code than the sort that's suitable for a webinar. So I hope that helps, that although I'll be talking about specific things, the techniques are very, very general. So my goals: to show you how to get untested code tested quickly and safely, to show the power of approval tests to do that, and to show how we can use CLion's code coverage tools to guide us in that testing. So let's have a look at the code. So this is a repository called Command Line Video Store, and if you've seen Arne's previous webinar, it'll look familiar to you. This is my fork of it with a few changes to set this demo up. So that's one thing I've got, and then the other thing I've got is this kind of to-do list, but I'm going to actually view that in a different application. So down the left-hand side, you'll see the structure of the demos that we're going to go through and a checklist of steps along the way. So that's for context for you and a reminder for me, and a reminder if you decide you want to go through this exercise again in future. So let's have a look at what we inherited from the previous webinar. So we'll have a look at the main. So the code of interest, the code that we're testing, is in the top level of this repository. So here's the main, and it's for a program called Command Line Video Store. And it is using a function called run, which is in run.cpp. So before we look at that code, let's actually run it. So Command Line Video Store. Now, I've got the resolution of my Mac set very small and the font set really large for the purposes of the webinar. So I'm afraid I'll be doing a fair amount of expanding and shrinking windows. So this is the application. It's showing a list of movies and it's asking for a name. So I'll type Claire, and then it's saying choose a movie by number, and I fancy watching Up, and I'll have that for 3 days. And I'll have Wally for, let's have that for 4 days. And then just enter for the bill. So that is the output. So it calculated the price of each movie, the total, and apparently I got 2 frequent renter points. So that's what we're testing. And the observant among you will notice that there's a test folder already. And that's the test that Arne started with. So we're going to pretend that that's not there. And we're going to go ahead and add our own tests. So we can say we've done those first 2 steps. Now, what I want to show, what I always do when I'm working anyway, but what I particularly want to demo is committing our changes at every working step, and once or twice at non-working steps as well. And I sometimes see people do demos where they work for an hour and then maybe commit the code at the end. I really want to encourage you always to commit small steps as you go, even to the extent of each refactoring operation that you do. It's a safety net for if something goes wrong, and it helps those who are reviewing code in future. And I will try to, I'm not going to be doing much refactoring of existing code, but I will always use the IDE's built-in refactoring options. Okay, so now for a bit of CMake and handle turning. So we've got nothing to commit so far, we've only run existing code. So let's have a look at the dependencies folder here. So there are several dependencies, several external libraries that I'm going to be using during this talk. And to save you seeing me type all of this in advance, I'm using CMake's fetch content facility to download dependent code we're dependent on, and to give a specific version that I want. So this is an alternative to using package managers like Kona and VC Package and so on, or installing. And I'm using this because it's convenient to show you, and it uses functionality that's built into CMake 3.14 or above. And each of these different calls will make available to us a library that we can, or a CMake target that we can add to our CMake for the program that we're building. So catch 2 is what I want for adding dependency on catch 2. So let's crack on and do that. So I'm going to do a lot of the file creation with right-clicking, and so I'm using the context menu. So I'm going to have a new test, and I'll call it, let's call the folder test2. And I always forget to do this, so I'm going to do this next. And in the parent directory, I'm going to add this new folder. And immediately I get a complaint because I haven't created a CMake lists file. So let's do that. And I'm going to use there's a lot of C's in this catch 2 CLion CMake. So a lot of CLion's context menus have this lovely feature that when they pop up, you can type and filter. So I'm going to make quite a lot of use of that for convenience and lack of typos and things. And then I'm going to have a file called integration tests.cpp. Okay, so let's start by populating the CMake file, and I'm going to grab some text from the top level program, from the top level CMake file. So let's have that and paste it in. And start running. And we're going to get a complaint that we've got a target of the same name. So I need to change this name. And there's a lovely feature that repeats the current selection, add selection for next occurrence. I've got a plugin installed that shows you, as I'm typing, shortcuts for almost all of them, what they're doing. So that saves doing find and replace. So I'll call this test2 and then hit escape to get out of the multi-line selection. And then CLion has a multiple clipboard history built in, and if I get the keyboard shortcut right for that, so that's Shift Command V, I can get back my catch2 string from earlier. Okay, so now we've got the dependency on catch2. Now, all of this stuff, it's a bit of faff, but I didn't want to just show you something pre-populated. I wanted to at least show you the steps that are involved. After this, there's not much setup. So catch config main is a hash define that we need to tell catch2 that we are going to we want that we need the catch2 header. I think it may be because there was an error, CMake didn't run automatically. So let's see what happens. Yes, okay, hooray. So that's all we need to set up our main. And I'm going to copy that line, copy to our test. Now I've called it integration test. For real world code, I don't usually find it very hard to think of test names, but for sort of short demos like this, I find it rather harder. But the point about this is these are actually from the start not going to be unit tests. We don't even have a small chunk of code. So let's the test case is how we start a new test in catch2, and I think I'm going to call it test empty input. Okay, and we need the header for the code that we're testing, so let's have include run.h. Okay, so we're nearly there. So we're going to call the run function. And let's go and see what it takes. Okay, so it needs an input stream and an output stream. And we'd like to try and avoid file handling for inputs to tests if we can. So I'm going to use the memory-based string stream. Not sure why that's not completing. So I'll call that in. And we will need to include stream. Okay, so remember that our function takes an input and an output stream. So I'm just going to say I'm going to pass in empty input and accept the output. And I'll say that I want out.str to be equal to, and we don't know what the output is going to be, but we know it's not going to be an empty string. But I'm going to be using a pattern throughout this. Let's go to, I've just seen that it's CLion. So CLion gives us really helpful feedback throughout, and I'm going to be really depending on its feedback during this webinar. And it tells me this doesn't belong to any project target, and that's because I didn't add it here. So thanks to the wonders of completion, I could just type the first couple of characters. That's probably why I wasn't getting help with the header earlier. So, and now I can see it's actually checked. Okay, so as I run the tests, I'm always thinking about what I'm expecting to happen. So I'm pretty sure that the output is not going to be an empty string. So I expect that this is going to be a failure. And it's not. And the reason is because I didn't tell it to run the new executable. So now let's tell it to run the new executable. And now I'm expecting we'll get a test failure. Don't worry about the time it takes to build the main. Catch2 takes, I'm running version 2 of Catch2, and that version takes a bit longer to build the main. And it gives us this really lovely helpful output. It's expanded up my out.str, and it's told me that's the output. So I will copy that text and paste it in, and let's use a raw string literal so I can just paste the line endings in. Oh, I've included the quotes as well in there, which weren't really supposed to be part of the output. So let's run that. So if I was feeling lucky, I might think it would pass, but I've probably got the odd line ending wrong on. Oh, it seems I've got the indentation wrong. Okay, so catch had indented the output. So let's remove that indentation. Let's run again. Okay, so I'm going to stop at this point and pause for a moment. And you can see it's close, but no cigar. I can see there's an indentation of this isn't quite right. And in the actual output, I happen to know there's a trailing space because I didn't give a name. And that's got lost here. So yeah, you could sit and watch me carry on for another 5 minutes and I could get the test to pass. But the point I want to make here is that when tests are hard to write, when they're painful, that's important feedback. You want to listen to that pain. And so I'm not going to carry on trying to sort of get this working. What I will do, though, is I will commit the changes that we've got so far. So what can we tick off? We can tick off all of these things. We've actually added a test with empty output. And we've tried to make it pass. It hasn't done that. So let's go ahead and commit those. And I'll just say add failing. It doesn't, well, I will say catch 2 test. You wouldn't normally do that for the demo. It's interesting. It's catch 2 test. Test for empty input. Okay, so let's go back to our slides now and see where we are. So what happened? Well, testing multi-line strings in code is hard. And as I said, you want to listen to the pain. But I do want to mention at this point that this isn't a limitation of catch 2. This, whatever test framework you're using, testing multi-line strings in code is hard. So let's look at an alternative way of doing that, an alternative approach. And we're going to use the approval tests framework to do that. So what we're going to do is we're going to make our test also depend on an extra library. So let's do that now so that CLion can be, catch can be updating whilst I'm talking. Okay, so that will trigger in a few seconds, that will trigger CMake to run. And then I want to add an approval test. In fact, I'm going to change our existing test and use approvals instead. Now, bear with me for a moment if you haven't seen approval tests before. I'm going to show you it in action and show you setting it up. And I think by the time you've seen it run, it will be fairly obvious, but I'll then talk a bit more about how it works. So let me open that link. So this is, we work really quite hard on approval tests on the documentation. For such a small library, it's got quite a lot of care taken on the documentation. You can see the docs either via markdown files on the GitHub repository or on read the docs, which I prefer because the formatting is really, it's nicer and it's easy to navigate and it's got a really good search. And so at the bottom of our details on how to use catch, we've got this code to crib for your first catch 2 approvals test. And that's all I'm going to show you at this point from the documentation. So let's go and crib that code. So our main is going to be a bit more complicated now. And that's because approvals works with multiple different frameworks. So you see all these frameworks listed here: Boost, Catch 2, CPU test, Doc test, Google test. So it needs to know what test framework it's working with, because it needs to listen out to the start and end of tests. So that's what's going on. We've got a slightly different starting point there. We're using the namespace for convenience, and also for convenience, I'm making some files it creates get tidied away in a subdirectory that it will create for us. Okay, so I'm going to get rid, I'll stick with the existing test that we created. And I'm going to paste some extra code in. move it around. Okay, so this is the magic line that we want, and I'll use that in a minute. I've actually configured my CLion to not reformat code when I paste in, and that was probably a mistake because I'm doing a lot of pasting here. So we don't need that, but we do need this. So let's move that to the top. Okay, sorry if that was a bit quick, but so we want the approval test header. It's released as a single header, but you can also use it with fetch content or whatever. And the same header is still available, and there's our using namespace. So let's run that and see what happens. So effectively, we've added a bit of boilerplate to enable us to call this approvals verify. So let's go ahead and run that. And I'm only passing in the number 42 at the moment. So we've just changed the main, so we've got a few seconds to wait for the main to rebuild. So the test failed, and then a diffing tool popped up. You see if I can increase the font size on this. Okay, apologies about that. Okay, I'll have to do it via... that's not going to be very usable. Okay, so it will be clear when there's more text in, but on the left-hand side, we've got our received file, and it just contained the number 42. And so what approval test does is you give it any text, any object, anything to approve, and it saves a text representation of that in a received file, and it looks for a file of the corresponding name approved, and that's its expected or required output. And every time you first run an approval test, of course, it doesn't know what the expected output is, so it fails. So let's actually give it some proper output. Let's give it output.str, and let's run the test. It fails again, and that is the same kind of output that we saw previously in our console. But by writing it to a file, we didn't have to copy and paste it into the source code and get the trailing spaces right and the new lines right and things like that. And so this happens to be Araxis Merge, the diffing tool that I'm using. But approval tests will look for any different tool of about 20 or 25 that it's pre-configured to know about across Windows, Linux, and Mac. If you like the output, then you use your diffing tool to copy the output from the left-hand side, the received side, to the approved side. And then you save the file and quit the tool, which I've done with shortcuts. So let's look at what we've got now. So approval tests has created, the running of that created these two files. And because of that line I showed you in the main, it's tidied them away in a subfolder. And there's a pattern here, a version control pattern that I'm just going to explain. It's important that you know about it. So the received files, those are temporary files from the running of a test. You never want to commit those to version control. So let's use CLion's lovely add to git ignore. And let's add that file to our git ignore. But of course, we don't want to ignore just that specific location. In all levels, we want to ignore all received files. And we might be saving JSON files or tab separated or whatever later on. So I'll say regardless of all format. Now let's run the test again, and remember that the only change I made was to approve the output. And this time the test passes. And so no diffing tool was open because there was no diff to show us. And also you'll notice that the received file disappeared because the test passed. And that's why it's easier to add the git ignore, edit the git ignore whilst you've got a failing test. So let's go back and look at our checklist. So we have added our first test. Now let's go back and look at the test that we inherited from Arne. So as a reminder, this is the test that we wrote. And in test 2, we've got, let me hide all of the windows. So here we've got, so a simple pin down test. Don't use this as an example for a good test. Well, it's a test that exists, so that's really important. It's got a bunch of input, and then this must have taken some patience to set up, but the list of movies and the output for that given set of inputs. So we've basically taken the same kind of approach, but approval test enabled us just to set it up quite a lot more quickly. So let's close all of these files except for our integration test. I'm going to hold down the Option key, which is a lovely thing that says keep that one file open and close all of the others. So I think that's a committable step. So let's remember to add to version control the, I should have shown you it, but there's that's the new file there. So let's say add approval test for empty input. Okay, so you've seen approval tests in action, but let's look a bit more at what's going on. So this is my favorite description of approval tests. It allows you to verify a chunk of output, such as a file, or an object, or some string, in a single operation, as opposed to writing test assertions. So at this point, when I talk about this, it's not unusual for someone to think, well, I wrote my own version of this. I know I did a previous job. But the power of approval tests is it's really simple to use. It takes care of the file naming and the creation of the files automatically. It's really easy to see failures, which I'll demo a bit later on. And it's really easy to update the expected output, which you do in your diffing tool. So it basically just works. Other common questions that people ask at this point, well, it's all very well saving a string, but I'm saving objects, atoms, molecules, who knows? And so I'm just showing screenshots of sections of our documentation. So this is the introduction to a page called String Conversions, which shows you the various ways from very simple to more complex that you can use approval tests on non-string objects, basically. I've also used it for verifying the content of images, and multiple people have used it for verifying sound objects, for example, by taking a synthesized tune or whatever and writing that to disk, either as text, as numeric data, as the sound wave, or images of the wave, all sorts of different ways of doing it. So at this point, I'm trying to let you know that these options exist. There isn't time in a 1-hour talk to show you the detail, just trying to show you the power and the flexibility of it. Another common thought is, but what if the output has changing data? So dates and times is a really common one. GUIDs is another one. And the jargon in approval tests, the vocabulary in approval tests for that is scrubbers. And a scrubber is a function that you either use one of our pre-provided ones or you write your own. And approval tests takes the output that was written by the verify function and then reads it back in and modifies the output. So that's, to me, that's a really lovely insight. The conventional wisdom with dates and times is you refactor your code to pass in a stable date and time object. Approval test says, nah, that's too complicated. We'll write out the file with all the dates and times in, and then we'll just scrub that text, and we'll verify the scrubbed file. And that's the kind of power that you get by using a library and an approach that's been implemented in a dozen different languages and being used in the trenches on huge amounts of legacy code at many different companies over many years. During the previous webinar, Arne said at some point his test started failing, and if I understand correctly, there was a problem with line endings, maybe the end of line characters. So I just wanted to mention that approval tests treats two files as equivalent, text files if they only differ by line ending characters. So that's another thing that is just a sensible default that works out of the box. Not going to talk about this in any detail, but these are the customization points. So you have control over how output is scrubbed or sort of sanitized if you need that. You have control over how the output files are named. So if you don't like the received and txt going in the same directory, you can put them in parallel directories, a received folder and an approved folder, for example. You can customize the writing to disk, which you would need to do if it was a non-text file. And you can customize the comparison operation, which you would want to do if it was an image file, to decide if you'll allow images, to allow some tolerance on the comparison. If the comparison says that the received and the approved match according to its definition, the test passes. If they differ, a test failure is logged, and then approval test launches what it calls a reporter. And almost all of the reporters are diffing tools. And so that's the name for what you just saw opening up with a Axis merge. And you can customize the reporters in many different ways, but I just want for now to let you know that's possible. This at the top is the URL for the C++ version of approval tests. And that obviously looks like a .cpp file name, but that's to distinguish it from approval test.python, .php, and the many other versions. You can see that this project, the C++ one, has been active from 2018 to 2021. And this on the right hand side is Llewellyn Falco, and he is the creator of the inventor of approval tests, and he's worked on almost all of the implementations. It looks like that I'm the co-author of the C++ one. I just wanted to mention that almost all of our work is done by pairing, but pairing on my machine. So it looks like I've done all the work, but it's very, very much an equal effort. And a lot of the speaking that I'm doing about testing in conferences has come directly from things I've learned from Llewellyn along the way. And I think this is powerful stuff that's worth sharing more widely in the C++ community. So I'm going to pause at that point and ask if there are any questions on what I've shown so far, which is catch 2 and approval tests. So, okay, so I can see there's a few questions in the StreamYard chat. Let's see if I can make it so that I can read that. It's quite hard for me to read it. Phil or Anastasia, I don't know if you're able to read them out. Okay. So someone said I actually have a philosophical kind of question to Clare on approval tests. Okay, it looks to me like there aren't actually any tests at this point. So we'll see if that's true or not.
Yeah, hi. There were no questions yet from the YouTube chat, but I had a few. Okay. If that's okay.
Yeah, sure.
Before I get to my questions, a couple of comments. First of all, I'm the developer advocate for CLion, but I actually learnt a new keyboard shortcut from your introduction, so thanks for that. That was the select next occurrence one. I hadn't seen that one before.
Yeah, it's fabulous.
And also a little comment on, again, your lead up when you were showing the catch test, trying to sort of replicate an approval testing type of situation, and how awkward it is to get all of the line endings and tab characters and things right. Just in case you do need that, you can run catch with -i to show invisibles, and that will actually render white space characters as /t and /n and that sort of thing. That can help, but obviously that doesn't take anything away from where you were going with it. So that was really good.
Thank you.
And I made some notes here. Right, yeah. So when you showed the approval test first running, obviously, first of all, it showed up the diff. You approve that, and then when you run it again, it all passes. If you run catch with -s, it shows the output even in the case of a success. What does that show you when you have a passing approval test?
So when you have a passing approval test, it doesn't open a diff tool, but the approved file still exists on disk, so you can open that up in the IDE and read it there.
Right.
Does that answer your question?
I think so. I'll just have to try that. It occurred to me I haven't actually tried that myself. So. And you mentioned about committing sort of every time you you approve, which obviously makes sense. I just wonder if there's any interplay there with local history in CLion, where often you don't have to commit as often when you're doing testing.
Yes, so I should show that actually. I was waiting until I'd made a mistake, and I was going to show the local history. It's a really powerful feature. What I thought you were going to say with Catch 2 was that Catch 2 itself has some Python-based approval tests for testing large amounts of its own output, which I think is wonderful.
I was perhaps going to bring that up later, yeah. I actually put it in some years ago before there was a C++ approval test framework, but it was partly prompted by seeing Llewellyn do a talk on approval testing at a conference. So yeah, that was useful. One final question before I think Anastasia has one as well.
Sure.
What about structured text like XML or JSON? Is approval testing a good approach there?
Yeah, so let me go back. Is my screen still shared?
It is, yes.
Okay, so let me go to that string. Let's see, right, strings, tips for designing strings. So one thing to say is that approval tests doesn't depend on any third-party libraries. Actually, that's not true. It's one thing we do support, which is the FMT library. So it's a kind of an optional extra that you can enable support for that. And then any formatting that you can do in format, you can do nicely there. We have some recommendations on how to format strings. My mouse is doing really weird things when I'm scrolling, and without a scroll bar, it's quite hard to demo. Okay, somewhat sadly, I'm going to admit defeat and go back to the GitHub docs, I think, which you can link to here.
I think it's all running in demo mode.
Yeah. Okay, so we've got how to do the string conversion, which I mentioned, but we've also got tips for designing strings. And this, a general comment on designing strings is that you want to design the output for readability and glanceability. So when there's a test failure, like say that the test that wrote this, it was writing out 52 instead of 50, or say all of the first values, the 4, the 50 and the 60 were wrong, and the different tool showed us that. You really want it to be glanceable. And so when thinking about the formatting, try and align similar values, and you'll get much more value from your tests then. I think there's something strange happening. When I switched between windows earlier, I lost the right-hand side of my window. Okay, I don't understand what's happened here, and that's going to make the demo quite hard. Let me just make the window a bit narrower, and I'll just have to live with that. That's I think, why I couldn't scroll earlier. I think, that's it. I accidentally scrolled in, zoomed in. That's a relief. So yeah, so what this page talks about is think about the context, what's useful for representing the data that you're storing. And it's perfectly valid to write stuff as a JSON file or a JSON-like file or XML. The C# implementation of approval tests does some things to make it JSON-like rather than actual JSON, to make it more human readable. We don't do anything like that because we don't want to add lots of third-party dependencies. We want people to just be able to download the single header and make it work. But it will play really, really nicely if you have your JSON library or your XML library or whatever, and you format the code, then it will verify it perfectly. Does that help?
It does. I think that answers half of my question. There's a bit more I want to maybe dig into later if we get time, but I do see that some questions have come in from the YouTube chat, so I'll just get to some of those.
Okay.
Someone's asking, how would a reporter work on a CI machine?
Oh, thank you. Yes, we try to detect if the tests are running on a CI machine, and we do that via environment variables that are set on for each of half a dozen or so CI machines. And so if it's found to be running on a CI machine, then it does a string diff. So it will invoke diff or CMP, depending on what platform it's on. So it gives you sensible behavior.
That's good to know. Thank you. And so just reading this for the first time. So refactorings are not working, highlighting is wrong, even though the project can be compiled correctly. What's happened? I'm not sure what that was referring to. But...
Yeah, I think I can comment, and
okay.
Arne also commented on that as well later in the chat. So that was referring to the situation when Clare had a CMake error for the loading of the project, and so the code was not highlighted properly. So yeah, and Arne is like completely right here saying that the project was not loaded because there was CMake error, and just as Clare showed, so the project after the reload, everything just was fine after that.
Yes. So I will use this opportunity to show what Phil mentioned earlier. So there's this lovely local history feature in CLion, and I can say show the history. So you can see the changes that I made. And at some point, there wasn't an integration test. I'd missed out the integration test file. So this is fantastically useful if you realize that you've made a mistake and you want to go back. My point was more philosophical about I want history and version control as well, but many times the local history has saved my bacon.
Yeah,
any more questions?
That's it from the questions, mostly in the chat, but I kind of have a philosophical question about the approval test, if I may. So
sure.
I got the goal about the verification, like how it works for the verification goal, but what about like learning the new code base, if it fits the goal or if it's the right approach to use for these kind of things? So if there is a completely new code base, should I like try doing some approval tests with it to learn about what actually is going on inside?
Okay. So one of the most common uses of approval tests is when you've inherited some code that you need to maintain for some reason. So I'd only settle in and start writing tests if I actually needed to fix a bug or add a feature. And because approval tests work so well when you give it a big lump of data to write rather than, before you can actually write small incremental unit tests, it's very commonly used in that sort of scenario where you've got, you might call it legacy code. You still have to go through the process of working out where there's a function that you can call, or a set of functions that you can call to put some data into the code that you're testing and get some data out. And I must admit, that's the thing that is a little bit artificial in this example, which it's really nice that it's got a stream that you can pass in and a stream that you can pass out. And for me, that's a great starting point. In real world code, you'd be looking for those themes. But approval test is a great way to explore doing that. And if there's time, I'll show you how we can use approval tests to learn more about the behavior of the code as well.
Okay, yeah, thank you. Maybe we can move forward and show some more stuff.
So let's look at what's coming up. So I do want to show the code coverage. So I have got some later versions of the code checked into a branch in version control, and I think I might jump ahead, but I do really want to show you the code coverage. So let's start with that. But I don't think there's time to actually use it to extend the code coverage. So I'm running Clang 11 on my Mac, which is one of the compilers that CLion understands for code coverage. And so code coverage is the idea that when you run some code, you explore which lines have been executed and which not. So let me ask CLion to run this test with code coverage. And it's a lovely, helpful message. Couldn't find code coverage data. You need the compiler arguments. Shall I fix it and do it for you? And this is a magical, magical thing that was added. Before that, I spent so much time fighting, trying to get the command line arguments right. And so you'll see a little bit of trundling for a few seconds. And what's going to happen is CLion is going to make a new build configuration with dash coverage. And now you'll see approval tests in any of our dependencies building. And then it will go ahead and it's got some indexing to do and things like that, but it will pretty soon start running the test. It's nearly there. I mentioned I was using CMake fetch content. A downside of that is for each of your build directories, the code is rechecked out and rebuilt. So this is what code coverage looks like in CLion. So it's telling us that 56% of the lines are covered in the function that we're testing. So anything in green down here, that's a line that was executed. Of course, it doesn't tell us that we actually tested the results, but it does tell us that the execution path went through that line. Things in yellow are things that for various technical reasons weren't fully covered. Perhaps exception handling, hidden code is how I think of it. And then the stuff in red is not covered at all. And for me, understanding this when I'm looking at legacy code is a really key part of working out whether my tests are good enough. And I'm not at all saying you need to get to 100% test coverage. But I am saying it's helpful to be aware of what isn't covered and whether you want to add more tests. So that's what the CLion's built-in coverage looks like. And you can turn that off by saying run and then hide coverage. But I want to show you another way. So I'm going to go to the settings, and there's a plugin called C coverage plugin, which I've got installed. And I tried really quite hard to make sure that everything was updated on my machine before this, in about, I don't know, half an hour or an hour before this webinar. It looks like JetBrains published this new version. It's a third-party thing, but I think that JetBrains reviews plugins and new versions before they're published. So I want to show you this in action. And so I didn't tempt fate by grabbing, I'm sure it's fine, and I think I've pretty much tested that version already, but I didn't want to tempt fate by changing the configuration of my machine. So that's the plugin that we've got installed. And then in the languages and frameworks, it has this section here. And the thing that's lovely is you can change the settings for different, so I've got a lot of different tool chains set up on my Mac for testing different compilers and things. And this is the one I'm using for this demo, and it's found automatically the associated coverage tools. And I've turned on enable run coverage action, and I've turned on this last checkbox option here. And by turning on that action, we get this extra run the test with the coverage plugin. So let's let that run. And it shows the results differently, and it gives us more detail. So you'll see we've still got the red and green, but it's showing the extents of the red and green between the curly braces. And it shows us where it's supported by the compiler. It also shows us using branch coverage as well. And so this exclamation mark shows that, so this condition is either been executed with true or false, but not both. And we can see it's gone into this case. So we only tested with the customer name was empty and not with the real value. And you can expand, if we had functions in here, you could expand and see the function names. It should and will soon show the actual function name, so do the demangling. We're not sure why demangling isn't working on my Mac. And this works on Linux and Windows as well. For me, it's really valuable to have branch coverage, and Phil will know that just as CLion's first version of code coverage was released, I was giving a talk saying, this is awesome, this is how you set it up. Please add branch coverage as well. And I'm really glad to say that is being worked on for CLion. And in this tool, you can click on clear at the top there to get rid of all of the coverage. So I really wanted to show you those tools in action. Let's tick that off. And we don't really have time to work through that, but I'm just give you, all right, I'll show you one more thing with that. So let's go to this, and no, okay, I am going to go back to the history. I much prefer to actually show it rather than just talk through, but I need to recognize reality at this point. So I'm going to revert that change. I'm not going to worry about saving it. It was just to the to-do list. So there will, after this, be pushed a complete run branch, and webinar is the branch that we're on now. So if I check out that version, so what we've got is an extra test where I've started putting in real input now, so real numbers. But we would find that this doesn't give us very good coverage. And that's because this is testing. This test currently is based on the data in the movers file. And you see that in the code, well, if you noticed in the code, the prices are different depending on if it's a regular movie or a children's movie or a new release. And I was only testing with movie number 1, and that's a regular movie. So I'm only testing the regular path through. So doing this would have slightly improved the coverage, but not very much. And so the normal way that we would demonstrate this would be to start adding loops here. So if you imagine I looped over all the movie numbers from 0 to 13 or whatever it was, and inside that looped over the number of days from, I don't know, 1 to 4 or something like that. And then we would end up with a larger approved file. So let's simulate that by having, so let's put in 10, which is a new release. Okay, so I'm going to run this now because I want to show you what it looks like when a test fails in approval tests. I'm not going to worry with showing you coverage at the moment. And so this is really important to see that when there is a test failure, approval test doesn't know how to show you what lines are changed. It just opens a differencing tool of your choice and you see the differences highlighted. And in this case, it's that we've got extra test output. But imagine instead that I had accidentally made a refactoring that had broken the code. I might see that only the output for one particular movie had changed, or only the output for a particular number of days had changed. But it's really hard to understand that in this output because we're not actually seeing the things that affect the code. We're not seeing the categories, new release or whatever, and we're not seeing the number of days. We're only seeing the price. So this is fantastic as an initial test to get our code, to make sure we don't break our code as we start refactoring. But I'm going to go on and show you the last stage of the demo now, just by checking out the code. And I'm going to force the checkout to ignore the edits that I've got already. Okay, so CLion behind the scenes is running. So let me, okay, so what have we done? If we go to run.cpp, what I've done is I've used CLion's extract method to extract out from the function that we were testing a function called calculate amount and points. And I was able to do that in just a couple of quick refactoring steps. And if you've extracted methods before, you'll probably be wincing at the fact that I've got two output values here. And it's kind of really horrible that this is doing two different things. But the point I want to make here is at the point of first adding tests, the goal is not to improve the maintainability and the structure of the code. That comes later. That's what Arne's video is about. So I've held my nose and automatically refactored this stuff out. And then we've used, I'm sorry to jump so many steps ahead, but you can look at this code and try it out later. But back here, we used approvals and we verified one thing. Approvals also has verify all, where you can pass in a container. So we could have said a container with a number of days and test with 1 day, 2 day, 3 days, 4 days. And then the kind of next generation beyond that is to pass in 2 or more combinations of input. And by extracting this function, what it's allowed me to do is to write a test that doesn't read the movies file. So the output is, the input is a category string and the number of days. And we're looping over all of those values. And then we get out the amount and the points, and we write it using the format library, FMT library, in a nicely formatted way. So this test will pass because the right answer is in version control. But I'm going to show you how I would go on to explore it, to explore the behavior of the code, which sort of tries to answer what Anastasia was asking earlier. So let's say I gave it a category that we know from inspecting the code isn't supported. And let's see how its error handling works with unusual numbers. And so just to explain what's going on in the Lambda, all of this in the rest of the code in the Lambda is all sitting around our call to calculate amount and points. So the Lambda receives one value from the category list, one value from the days, inputs 2 it's called here, because that was just copied and pasted from the sample code that we have for this. So our test is now going to fail because I've changed what's being generated. And that means that a different tool will pop up. So normally when a test fails, the question you're trying to answer is, have I improved the behavior or have I broken the code? But here we've changed the test. And we can see the new lines that are written out. We can see the lovely alignment thanks to the format library, and we've said write out 2 decimal places. But we see the lovely thing that if it's a new release and we ask to rent for it for -1 or -2 days, then the renter gets owed money. Now, my first thought was, well, that's a bug and we should fix it. But you have to be really careful when you're changing the behavior of legacy code, because it's possible, just possible, that in the real world, someone is using this as a way to give a refund. Maybe the system can't give refunds. And so for where the company made a mistake, staff were told, oh, just put in a negative number of days and we'll do the refund like that. So don't fix the behavior of existing code without talking to a product owner or domain expert. So that's a lovely thing. Another lovely thing about approval tests is once you've got the coverage, you can use it to explore and learn about the behavior of the code that you're testing, and have conversations to decide what to do about that. So we talked about code coverage. The fact that CLion auto creates the configurations is amazing. We saw how CLion shows coverage data by line and how it highlights the code. We talked about the plugin. I want to say that Marcus, who wrote this plugin, has been really, really helpful to me over the last week or two as I've been setting this up. And JetBrains also has given me help with getting code coverage working on Windows as well. So thanks to everyone involved in that. This coverage is amazing. This tool is amazing. As a novice user, I would like to contribute some text to its documentation to help people get started with it, but the behavior of it is fantastic. I'm going to skip past any questions at this point and go on to my summary, and then we can combine the questions at the end in view of the time. So I showed you how to change this particular test to not depend on production data, but I hope you'll see that that's a general point. That's the point being that at some point one of those new releases might have become an ordinary movie. It stopped being new anymore, and then our test on that data file would have started failing. We talked earlier about formatting, designing strings to make them easy to use. And if you haven't seen it, the approach of fake it till you make it, of write the output that you want to generate and then gradually modify the code and put in the formatting and put in the values is really powerful. A few brief CLion testing tips, and then we're done. So in case you don't know, CLion has many ways to control what tests that you run. And the trivial 2 or 3 tests we had today, it's so quick, we're just going to run all of them. But you can right-click on a test source file and tell CLion to run all the tests in that file. This truncated text is because I'd got the font so large for the webinar. You can, next to an individual test case, you can click on the green arrow button, or you can right-click and debug, get coverage and so on. Also, in the toolbar at the top, you can run the entire executable. And it will run all the tests in that executable. Or as a lovely recent addition, which I'm incredibly grateful for any test programs that are registered, any tests that are registered with CTest, CLion now detects that and it creates a new target, which is to run all of the CTest tests. So then if you've got that selected, clicking the build hammer will build all of your tests, and then the run will run all of them. And in the approval test project, we've got 15 or 20 different tests, test programs implemented with about 6 different test frameworks. Being able to run them all in one go is just wonderful. Also know the test runner tab. I'm not going to go through here, but there's a lot of functionality in here around filtering tests, running them multiple times, only running the tests that failed, seeing the output from individual tests. It's really powerful. And then I think this is the last hint. In a real world project where you've got lots and lots of libraries and test programs and your production code, it can get quite cluttered quite quickly. And I wanted to show you that when you're editing configurations in CLion, you can select related things and then click on the Move Into folder. So these 3 things are my dependencies that were pulled in with fetch content. I'm never going to want to run them. I could do the same with the library for this code. That's not a runnable thing. So you click on that, you give it a name. I called it dependencies. And now when you choose your configuration, you only see at the top level the things that you're interested in, and everything else is hidden away. So I'm always constantly learning new things about CLion, and it's really worth exploring with functionality that you use all the time, because there's so much power and convenience built in. Lastly, I just want to say know your icons, and you probably won't get tripped up by this, but particularly when you're adding new executables, you might. And so here, instead of test 2, I'd called my new test more tests. And you can see I've got more tests with this icon here, more tests with this icon here. If it looks like this, CLion knows it's a catch test, and it's going to run it with the catch runner. And so you get the functionality I just talked about, selective running. If it's like this, CLion just sees it as any old CMake executable target. So you can run it, when you get the output, you get the normal console output from your test runner. And depending on the situation, maybe you created the executable and you forgot to add the catch2 dependency, which is what happened to me earlier today. Or maybe actually you don't want to run it via the test runner, you want to run it and see its normal console output. So the other thing to say is if you've got a whole load of these kind of plain icons and then one or two catch ones or Google test, it's really easy to look down this list and not notice the other icons. And so just, it's probably not going to trip you up, but it's a feature that's occasionally a pitfall. So huge thanks to JetBrains and to Marcus Burke for apologies if that pronunciation is off, for major contributions to my understanding. And thanks also to Llewellyn Falco, as I mentioned earlier, for approval tests. Tactics: assume tests are possible, listen to the pain when you're writing them, and coverage is there to help you. And that is my last slide. I think we've got something like 5 minutes for any questions. Well, thanks everybody for your attention.
Thank you very much, Clare. Yeah, there were a few questions in the chat, which I will probably try to address on my own. There were mostly, like, quite a lot of questions about the remote mode. And I would like to say that, yeah, so CLion has a full remote mode when you can actually, like, compile your code and run it and run the unit tests in remote mode. There was also a question if you can, like, compile on one machine and run the unit test on another machine. So, like, you can do that, like, try like copy the executable and run it manually. CLion can't do that for you automatically. It can, like, do a remote debug session for you, but not like build on one machine and now, you know, run the unit test using the built-in test runner on another machine. But
can I just
that's
add
a nice
quick
scenario.
Yeah, can
sure,
I just add a quick comment about approval tests, because that is quite an important thing to be aware of with approval tests. So I mentioned that it generates a sensible name to set for the approved and the received files, but I didn't point out that it gets that name and location based on the source file. And so the test frame, all the test frameworks have a way to say this test was running in this file. And we don't have anything built into approval tests for if you've copied the executable to a different location than where it was built in the first place. We have a pull request for an initial implementation of that, but if there's anyone who would like to work in that area, if they've got a real world example, I'd love to work with them and add support for that, because it will help with all sorts of different scenarios. Thanks.
Yeah, thank you very much, Clare. There were also a few questions on various project models, I guess, on Makefiles and on, I see one on Mason. So regarding the environment variables for Makefiles, I think they're not yet supported, but that's something we probably can look at. And yeah, no Mason for now, but you still can use the compilation database, which is kind of universal, you know, project model for everything, because you can generate it out of, you know, completely everything and use it in CLion as a project model. And yeah, so thank you, Clare. And I think to wrap up, we can switch to my final slides, just because we're running out of time a little bit. So will please show the slides. Okay. So yeah, I answered already in the chat that the webinar is being recorded, so the recording will be available, and there will be a blog post, and also we'll follow up with announcements on Twitter and emails. And you can learn more about the CLion on our site, jetbrains.com/CLion, and there is a very useful web help where you can find all the details about how to set the unit testing, the coverage tools. All these things are covered in details in our web help. Please follow us on Twitter and check out our blog, which is blog.jetbrains.com/CLion. And also you can find Clare on Twitter as Clare Macrae UK. So, and find all the details and ask her any questions. And with this, thank you for joining. And that's it for today. Thank you, everyone. Bye.
Thanks very much. Bye-bye.
Bye.